All right. Hey, ratio test, like I showed you yesterday, my notes, ratio test comprises about 7 lines of my notes. So it's incredibly easy to teach, but it's very sublime to do. I mean, you guys got to get good at ratio test, because then we're going to go back to power series, what we were doing at the first part of this chapter with Taylor series and Maclaurin series. We're going to go back to power series, and then you're going to be doing ratio test all the time. Just every problem is going to require ratio test. So you'll get good at it just because you have to do it a lot. So here we go. Here comes ratio test. Ratio test. Here's what it says. Let the sum of A sub n be a series with non-zero terms then what you're going to do, rather than getting a ratio between A sub n and some other series that you've chosen, or instead of comparing A sub n with some other series, what you're actually going to compare is the nth term with the n plus 1th term of A sub n. So there's no B sub n's happening here. Here it comes. If the limit as n approaches infinity of the absolute value of A sub n plus 1 over A sub n, if this limit is less than 1, then the sum of A sub n converges. If this ratio is greater than 1, then the sum of A sub n diverges. And if this ratio is equal to 1, then the test is inconclusive. You got to choose another test. Test is inconclusive. Choose another test. That is, you're going to have to choose, integral test or direct comparison test or limit comparison test or, something like that. Nth term test for divergence. Okay, hey, let's do one. Example number 1. Does the sum as n goes from 0 to infinity of 2 to the n power over n factorial? Wait, what am I getting? N factorial. Does this converge? Well, first of all, just guess. What do you think? Do you think that thing's going to converge or diverge?
Converge.
Okay. Well, we got one converge. Who said that? Was that you, Chris?
No.
Was it you, Andrew? Okay. How many people say this guy converges? How many people agree with Andrew? Okay. How many people say it doesn't converge, it diverges? Okay. Well, let me ask you this. 2 to the n or n factorial, these are both going to be infinity, but which is the bigger infinity? Yeah, in fact, how much bigger is n factorial than 2 to the n?
Infinity.
Yeah, infinitely bigger. So now, having that in mind, how many people say this guy probably converges? Well, good for you. Yeah, because that's it. But let's go ahead and do the ratio test. In order to do the ratio test, all you have to do is know what your A sub n and A sub n plus 1 are. That is, whatever your nth term is, you've got to get the next term. And all you have to do to get A sub n plus 1 is just put n plus 1 in for every n. So I got 2 to the n plus 1 over n plus 1 factorial. You see that? It's that easy. The n plus 1th term, just stick n plus 1 in for every n. Now we're going to do this limit. The limit as n approaches infinity of the absolute value of A sub n, 2 to the n plus 1, over n plus 1 factorial, over 2 to the n over n factorial. Okay. I've got to find out what that limit equals to. So the first thing I'm going to do is say, well, if I'm dividing by a fraction, that's the same as multiplying by the reciprocal. So I'm going to say this is the same as the limit as n approaches infinity of 2 to the n plus 1. Let me see, I'm going to multiply by the reciprocal, so it's times n factorial. And then what I still have in the denominator is 2 to the n times n plus 1 factorial. Okay? Are you guys okay that I just took this fraction and multiplied by the reciprocal?
Yes.
But I kind of grouped them so that the 2's would be over each other and the n factorials would be over each other. Alrighty, let's cancel. Tell me, what's 2 to the n plus 1 over 2 to the n equal? What is it?
1.
Not 2, 1. Yeah, 2, right? If this was 2 to the 7th and that was 2 to the 6th, then they would cancel to be just 2. Or if this was 2 to the millionth and 1th, and this was 2 to the millionth, then you'd have 1 extra 2 on top. So that's 2. Now here comes the next thing. N factorial over n plus 1 factorial. What's that? N plus 1, where does that go? In the denominator or numerator? Okay, Zach says n plus 1 goes in the denominator. I'm going to put it down because Zach is almost never wrong. But someone explained to me, how did Zach know that? How does n factorial over n plus 1 factorial cancel to be just n plus 1 in the denominator?
Factorials cancel out.
I mean, yeah, they cancel out, but I want you to be more specific. What's that, Abigail? If someone doesn't answer, I'm going to have to ask Zach. Yes, Daniel?
The n is one term ahead of the one on top.
Thank you. This guy is 1 term ahead of this guy. You guys okay with that? And Zach, is that what you were thinking? Yeah, that's it. And if you need to write it out, be my guest, right? N factorial over n plus 1 factorial. N factorial is 1 times 2 times 3 times 4 times 5 times n minus 1 times n, right? That's n factorial. You go from 1 all the way to n. N plus 1 factorial is 1 times 2 times 3 times 4 times 5 times n minus 1 times n plus 1, right? N plus 1 factorial just says you go to n plus 1. You take the same path, you know, you just go all the way to n plus 1. And then as Daniel said, I got 1 extra term. This guy's 1 term ahead. All of these guys cancel. They all cancel, leaving you with just 1 over n plus 1. So you guys are good with that. So now what's this limit end up equaling to?
0.
Good, 0. 0. So does it satisfy one of these 2 criteria? Yeah, it's less than 1, which means what does this series do? Yeah, series converges. So, and the important thing is not that this be finite, it's just that it's less than 1.
Oh.
You guys ready to do one on your own? Okay, here it comes. Here, you're going to do this one. Example number 2. Does the sum as, I'm so sorry, I lost it. Oh, here we go. N equals 0 to infinity of n squared times 2 to the n plus 1 over 3 to the n converge. Good luck. And you're going to do it precisely the way I did this. Write the nth term, the n plus 1th term, and then do this limit. And let's see how it works out for you. by now, you should have been able to write down what your a sub n and a sub n plus 1 terms are. Did everyone get that far? Okay, then let me show you a little bit of trickery. I just want to make sure you can set it up. Next, remember, you're going to be, instead of dividing by this fraction, you're going to multiply by its reciprocal. But I really like to organize things. Like if this numerator is n plus 1 squared times 2 to the n plus 2, then when I divide and these two guys end up in the denominator, I want this guy directly under there, and I want this guy directly under there. It just makes it easier for me to see visually. And then this 3 to the n is going to end up in the numerator, and this 3 to the n plus 1 is in the denominator. You guys okay with that? Okay. Here comes some more trickery. The limit as n approaches infinity of n plus 1 squared over n squared. Do you know what that ends up equaling?
1.
How'd you get 1?
Because when you multiply the fact, when you, I guess, distribute the n plus 1, you get n squared plus 2n plus 1.
Okay.
And then you take, since infinity squared is infinitely greater than the 2n and the 1, you count those as insignificant, and you're just left with n squared.
That's absolutely beautiful. You guys okay? He just squared this out and then only looked at the leading terms, and he got 1. There's another way to think of this, which is the way I use, but you can do it, Andrew's way, that's fine. What I do is this. I go n plus 1 squared over n squared. I'm just going to make it one big term. Okay? And now, as n goes to infinity, what does n plus 1 over n go to? 1. And 1 squared is 1. Now, if this were n, if this were infinity, that'd be a different story. This ends up equaling e. But this isn't infinity. This is just 2. Yeah, 1 squared is 1. So that's the way I think of it. I tend to just rewrite this like this. But Andrew, your way is fine. So this guy ends up being 1. What's this guy over that guy going to get me? 2. What's this guy over that guy going to get me? Yeah, great. And we know that this limit, as n goes to infinity, this guy goes to 1. So what's the answer? 2/3. So does this guy converge or diverge? Yeah, this is less than 1, so this series converges. Okay. Hey, that's it. That's all there is to the ratio test. You're just going to write down the nth term, n plus 1 term, and get the ratio of them. So now, let me wait till you guys write that down. So you'd say converges by the ratio test. So let's talk about the meaning of the ratio test. Why does it work? What am I finding here? What am I doing? Anyone have an idea? Like, why is it that less than 1 converges and greater than 1 diverges? Yes, Zach?
You're like finding out if the next term will be smaller.
Okay, you're finding if the next term is going to be smaller. Okay, but tell me more. That ratio, yes, Zach?
But since it goes to infinity, wouldn't that, if you go to infinity, wouldn't that be called all succeeding terms are smaller than the term before?
Okay, great. Hey, you tell me, how much smaller? Yeah, 2/3. Every next term is going to be 2/3 of the previous term. Because remember, I'm getting the ratio of the next term to the previous term. And I'm finding here that the ratio of the next term to the previous term is going to be 2/3. When n gets really, really big, I don't care what the term is, the next term is 2/3 of that, the next term is 2/3 of that. Well, what kind of series is that? What kind of series am I describing here?
Geometric.
Yeah, geometric. That's a geometric series. So essentially the ratio test is saying, hey, if, for small values of n, who knows what your crazy series does? But for big values of n, if your series resembles a geometric series where r is less than 1, you've got a convergent series. You know, because the first bunch of terms, you add them up, that's going to be a finite number. No matter how many terms you have, the first, million terms, you add them up, you got a finite number. But then after that, if your series is acting like a geometric series where the r is less than 1, then it's going to have to converge. You see? But if it acts like a geometric series where the r is greater than 1, then it's going to diverge. But if it acts like a geometric series where the r is equal to 1, then you don't know. Then it's inconclusive, Because if each succeeding term is about equal to the next term, you don't really know. You could have 1 over n, or you could have 1 over n squared, You don't know what you've got if the infinitieth term is about equal to the infinity plus 1th term. But definitely less than 1, it's going to be convergent. So that makes sense to you guys. All we're doing is using the ratio test to say, hey, as n goes to infinity, does this guy act like a geometric series? And this one does. What if I change the problem? What if instead of a 2 there, what if I had a 4 there? Then what would this series do? Yeah, diverge. Because if I stuck a 4 there, then this guy right here would be a 4, and so then it would diverge, Because it would act like a divergent geometric series when n goes to infinity. Okay, well, hey guys, now it's all just up to you to do lots of problems. I'm done. Any questions or issues? Then you got 15 minutes to kill. Bye-bye.